I'm going to do this a little unscripted, but the plan is to go through developing a small application using Angular, SignalR, get some things popping up on each page, add a component, and see where we go. We'll see how long it takes. This is primarily for Gensol. So we'll see how it goes. Okay, so we're going to start with opening Visual Studio. And we're going to have a command prompt open, because you can always use a command prompt. Make the videos, make the Angular SignalR. So I'm going to make this and try and capture the mistakes, but also explain why I'm doing everything. I'm not pretending I know everything about it. I'm not primarily a front-end developer. I have to do it, and normally I learn what I need, so we'll go from there. So let's create a new project, and we are going to create a new ASP.NET Web Core, ASP.NET Core Web Application. Hit next. We're going to store it in our directory that we just created. Videos, and it's going to be called Angular SignalR as a solution name, and the project I'm just going to call View for now. And we're going to see what sort of structure it's going to create. So sometimes the structure you get out of the tools is just what is easiest for them to produce, not necessarily what you wanted to do. So I've got .NET Core 2.2 installed. If you've got the latest tools, this might be there. .NET Core 3 is on the way, but it's still in preview. If you're using Visual Studio 2017 or earlier, you can't use this version of the SDK either. That is a gotcha. This is the highest version you can use in Visual Studio 2017. There's some incompatibilities, and I believe a new build tool. In a new build tool in here means that it's incompatible with older versions, so they have to keep moving it forward. So if you're installing .NET Core 2.2 and you're using Visual Studio 2017 or earlier, use this version. Okay. Point made. We're going to select Angular, so we're going to go with the basic Angular template, and we're going to leave it configured for HTTPS. You can turn this off if you're just developing a site for playing around with. It adds another port, it does some other stuff, but I'm just going to leave it on because it's the quickest way through, right? And you can see the SDK version here. I'm using 2.2.203. So I'm going to hit create, and that will go off and create a project. Now, before I touch anything else, I'm going to check that the structure of the folder that it created is what I wanted. So what I'm going to do is I'm going to close the solution. The reason I'm going to close it is because if I have to make any changes to that directory structure, this will screw it up if it's open. Okay, so let's ls in here, so you can see it made a solution. Okay, and it made a folder called View, and there's our application. Now, I personally don't like, I kind of like the style of putting all the source files for something underneath. So what you may see in some applications is something similar to this. So we're in the View folder. We're going to go back up to our main directory where our solution file is, and our user file, and our View. I'm going to make directory called source or source. It's a way of organizing files. So if I had documentation and stuff, they might all live at this level. If I made docs, you might see libs here for things that get included, but you don't want to get mixed in with everything you're developing, right? Then I'm going to move view into source. So now I should be able to do this to see the source. Now when I move down in there, I want to see the view folder. One other thing I'm going to do is I'm going to start using GitHub to track the changes, or Git to track the changes. I'm not going to commit it to GitHub today. But a good way of getting started to make sure that you're not committing things to your repository is to always start with the repository. So I'm going to do this. vi.git ignore. Okay. And it's going to start a new file. That file didn't exist before. I'm going to go here. I'm going to search Visual Studio git ignore. Now this is an ignore file that someone has made already. GitHub has made already. This is the default ignore file for Visual Studio. These are all the files that it creates that you don't and probably don't want to track in your in your repository. You don't want the bin and object files committed to the debug, to the repository. My apologies. You don't want the bin and debug files committed to the repository because they're files that aren't change tracked. They're always changing, right? You don't want them there. They're built when you build the application. There's no need to track them. Similarly, user and SUO files, they don't need to be tracked because they are options that I've set up on my machine that deal with how I deal with this code base, including paths and setup and web builds, etc., so that each user can have it set up. It doesn't affect them. Then there's a whole lot of other files. PDB files. PDB files are debug files that are built when it builds the code, and you don't want them committed because they're binary files that are built when the code is built. They change all the time. And this is covering everything. There's other languages that the Visual Studio uses, C++, Visual Basic, etc. So this is covering all those things and other tools that it uses. So what we're going to do is we're going to click raw, select all that, so Control A, Control C. Then I'm going to go back here, and without doing anything else, I'm going to hit Shift and Insert. And when it finishes drawing, I'm going to hit Escape. Then I'm going to do colon WQ. If you were using command here for this, command prompt instead of git bash, okay, what you might do is notepad, so rm.git. I'm going to remove the file for it a second. If you're using notepad, you might do .git ignore, create the new file, paste in the contents, Control V, save and close. And now you can see .git ignores there, and I can go back here, and there's my file. Okay, there's all the file. So that's both ways of doing that one. You can't easily create that file using Windows. If you're not used to using a command prompt, you can't easily create that file because in a Windows directory, and again I'm assuming Windows because it's the safest bet, you cannot create a file. So let me delete that once more and delete it from Windows. You cannot create a file without a file name. Right? I can open it in Notepad, but I cannot save it. Okay? So when you see directories with a period, they're normally created specifically to hide them from Windows. And Windows will by default hide them, but it will show them eventually. So let's do that once more. Notepad.git ignore. So you see, Windows will let me create them. It just won't let me create them through Explorer. So there's our git ignore. Now before I initialize a repository here, I'm now going to open the solution. And what you're going to see is, oh, my view, I move the directory. An SLN file, a solution file, keeps track of where, that's actually done bad things to Visual Studio as well. An SLN file keeps track of where things are. It doesn't really do much else. Sorry. Let me close. I need to kill Visual Studio. It looks like Visual Studio is not doing good with that. Let's wait for that to close. Okay, so let's open Visual Studio again and try that once more. See if it recovers better this time. Okay, so you can see our view is unloaded because now our project's disappeared as far as Visual Studio is concerned. So there's two ways of doing this. You can go in and edit the solution file. So you can edit this with Notepad. You don't want to check always use, otherwise you'll never be able to open a solution using Visual Studio. And what we can do is change that to source view, and then we'll get prompted to reload. We reload, and there we go. There's our project. So now we got a site. Let's make sure we can build. By default, the project is going to come with needs of NuGet packages. So in the bottom here, you can see it's going to restore them. And it's going to build what it needs to actually run the project. And then we're going to run the project. He says with confidence as Visual Studio is taking a complete and utter... Oh, no, it's still restoring. NPM is the node package manager. It's running in the background to restore all the Angular dependencies. It's part of the build now in Visual Studio. Older tutorials will not show that. They might need you to go into a directory and do npm install or npm update, etc. Visual Studio's come a long way in the tooling. Okay, so now we've got build succeeded. You can see our UI has become responsive again. We've got buttons and stuff. If I hit F5 right now, it will open and we'll have a website. Fingers crossed. So it might seem like it's taking a long time, but what's happening in the background is it's actually building all the components it needs when we ask for the site. It keeps building in the background. This is just in time, I suppose. It's building everything so we can change things, we can keep working with the site, we can keep moving back and forth. And as is the standard, we have data being retrieved, we have a counter being counted, and we have our project. So now I'm going to close that site down. I'm going to close that down. Now, what you might find is it's easy to keep the tab open with the web page there, and you just keep wanting to run. So I'm going to go into my properties. I'm going to go into debug. and I'm going to uncheck launch browser, which means when I hit F5 or I hit the play button, it's not going to open a browser window every single time. It's going to start the application, and I'm going to be able to refresh a page if I've got one open from a previous session. I'm not going to have to keep having it pop up with a brand new window. So now we've got our basic site. Now is a good time to commit the changes. It's a good point in time. So what I'm using is Git. If you haven't got Git installed, you can go to Git for Windows in Google or your favorite non-Google search engine. Others do exist apparently. And you're going to get to see this link, gitscm.com. So if we just click that, you can see you can get a download for this. That's what I'm using, and apparently now downloading again. Similarly, there are tools in Visual Studio to do this. So if I go into Team Explorer, and I can see the repositories I've got locally, right? I can say new. And then if I select my videos, Angular Signal, right? That's our root directory. And hit create. Never mind. You can't initialize a repository from... Oh, I know. Yep. There we go. I'm going to leave that in the video. I don't use these tools all the time. I do know they exist, and I do know they're a way to get connected to the Git tools without a full Git install. They're installed as part of Visual Studio by default. But I believe what we can do, and I'm going to figure this out as I go. Add solution to source control. So what that's doing is here is now creating a repository from our solution. So now if we go back to Team Explorer, there's our Angular Signal. So if we double click that, it will take us to our changes. Now, you may ask, why am I doing this? If you're going to screw around with something and you've got a good working example, you don't want to have to keep going back and recreating it or figuring out where it was last correct or just giving up because it's got messy, right? You want to be able to be safe in experimentation. So I'm going to go to changes. And apparently there are no changes, so it must have initialized the repository. So I'm going to go back here. And I want to see there's no log. Okay. When it says manage connections, it means to a remote repository. Yeah, what it's done is it's initialized the repository and added everything that it needs to add. Right, added project files. So it's created an actual repository for me. So I have nothing to do, and I can confirm that in here by git status. Yeah, everything's clean. I have a log. Add git ignoring git attributes. Add project files. It may. Oh yeah, it's replaced my git ignore. So by default, Visual Studio will create a git ignore and ignore most of its files for you. How useful. So for the rest of this, I'm going to use Team Explorer to show everything. Okay. So now we have our project. We have it checked into Git. I go in here and I enter a load of crap and I delete this file. I delete this file. And then I'm like, oh crap, I've ruined everything. I don't know how to do. I want to get back to there. So now if we go in here and see, if I hadn't been in here already, I can go into the repository. I can click changes and I can see that I have startup.cs is changed, and error CSHTML and error CSHTML CS, the code behind for that file. What did I do? So if I right click on this and I show, I can do blame. I can see who changed it last. I can say compare with unmodified. So what has changed in this file? What this is showing me is that this said env.is development, now says env.is developers, and I changed else to fast, and I added some characters and basically lost my tempo with my keyboard. Oh, no, I don't want that. That's not good. So we can right click and say undo changes. Yes. And back it goes. And now it disappears from changes. If I right click this, undo changes. Yes. Right click this, undo changes. Yes. I now have no changes. And in my repository, here's my error.cshtml. Everything's back. I can hit run, F5. Now remember, I have no browser to open up now, so I'm going to have to be remembering what URL. Oh no, what URL do I use? Let's go in here, properties, debug 52472. Okay. And also by the default, Visual Studio by default uses IIS Express. It's down here. If you right click it, click view, it may also hide it up in here. If you right click it, hit view, there's our site. I can click that and the browser window will open. And there's our site. All intact, all working. We've got a point in time to go back to. Okay, so Angular. We're going to use Angular. It is a web framework. There are others. React and Vue are commonly mentioned. There are others. But Angular is a used framework in production code around the world. And we're going to use this today. So let's go and explore Angular. So when you create a template for a Visual Studio Angular application, it will create a folder called Client App. That's what gets run when we start the project. It uses a little bit of magic. If we go into our startup.cs file, you can see that it says in here, add spar static files. This is the way the Visual Studio or .NET Core is being wired up to tell it where to find its JavaScript from. Okay, so when it's being published, this is where you're going to find your actual application to serve. We then come down here and we say add use spar app.useSpar. That's our application builder, and we set a source path, which is here. Okay, and it calls start when it starts up the Angular CLI server. So we have to use two components. We have a client side and we have a server side. This is what wires it up. This is what starts the actual application up and running. And that is in here, AngularJS. No. Beep. And that is in here, in our package JSON, it will call start. which is ng serve. Okay, so it will serve the Angular application alongside, and everything will communicate. Now the Angular application will be served on a different port than the ASP.NET application. That's an important thing to remember. It will start up Angular. Once it's built, that will be provided by the browser, but these are the tools that Visual Studio uses to wire everything together. So you can debug it, test it, etc. So this is only done when it's in development. Okay, you don't really need to worry too much about all this sort of stuff. Most of it's set up to help you get an application up and running out the door. Okay, so let us get working with Angular. We have a source directory. The source directory contains the actual application. Okay, it contains how to start it up, the page from which it will run. Okay, so this is the view you see at the title of the page. It then has the environments, and what these are things that you can use to set up the application when you're doing it, using it for different environments. You can add more environments in here if you have a staging server or you have other servers. There's other things you can do. It's wired up to deal with helping you support the application. In app is where the meat and potatoes of the actual application is. We have our app module, okay, and the module is the root of the application. It's the actual module that gets started when the application starts up, and it contains information or the files that are included to tell Angular, hey, I know about this piece, I know about this piece, I know about this piece. Okay, Angular is made up of components, modules, services, etc. You'll learn more with a bit more of a deep dive, but to begin with, we're going to cover adding something into a component, adding a new component, and making things talk using SignalR. That's the goal of this. A deeper dive into Angular isn't really where I want to head right now. And again, like I said, I'm not an expert on this. This is not me pretending I know everything about it, and I'm not going to pass that off. So if we're looking main TS is started by the rest of the process, and when the app starts up, it will load, it will figure out what the environment is. Okay, you see it includes environment, it doesn't include environment.prod, etc. When you build, you hand an environment variable to it, and it includes that file. So then we end up with environment.production, enable prod mode. Prod mode is everything's is compressed more, it's not, you can't debug on the browser as much, and the application is much faster and much smoother to run. Okay, so let's get into the actual application. Let's not mess around with too much more right now. So the way the application is made, we have our app module, and it has routes. The router is similar to when you go to www.twitch.tv/TBDgamer. Okay, this is the route to which you're going, right? So Twitch is set up to say, okay, when I see something after here, I need to navigate. If you need to go to search for channels, or chat. So if you want to see just my chat window, right, you can do that, right? And you'll see the chat for my channel. This is a route. So Angular needs a way of being able to send you to a page, but also it needs to be friendly to someone needing to save that URL, right? Angular can't just say, okay, here's a URL, because it would direct to a file. Web servers are made to direct straight to a file. So when you go to if you go to twitch.tv/channels, right? This would direct to a page called channels, right? TBD Gamer doesn't direct to a page called channels. It's a name that is processed and then figured out, okay, we need to show this page, and it's going to be this page with these numbers in it and these IDs, and this is what it's going to look like. They don't hold a page that looks like my site, my layout, and they don't hold a page that looks like your layout, right? They have components that are loaded in. So this is what the router is in Angular. It will look like a URL, but it will intercept it before it becomes processed by the browser, and it will figure out how to draw what you need to draw and plop onto the page. So if we see here, we have path empty, which means the default path. This is where you're going to land by default. Counter and fetch data. If I look at the application again, there's home, that's this page. There's counter, and there's fetch data. And the way you know it's not an actual URL is if you watch, there's no flash. Okay? In Twitch, if I go to Twitch TV and I go to a person, yes, it is loading up a page, but that page is being loaded and then set, right? So everything loaded then. If the headers and stuff don't move, and you can actually you can see this doesn't change, right? This isn't a full page refresh. This is loading components into the page. So that's how you can tell. There's no flash. If you click on this now, you'll see the page will load, and I'll navigate, and I'll come away from the site. Right? There's a flicker. If I go to counter, fetch data, there's absolutely no flicker. I believe you can make that loading icon show. That's how that works. Right. So let's start with the home component. So the home component is our default landing page. An Angular component is made up of two pieces, or two components, right? It's made up of a code behind file, home.component.ts, and that's a naming convention. You can call that anything you want. It's just nicer to name it the way that it fits, so you can see at a glance what it is. And it helps the tooling to do it that way. So we have home.component.ts. That is a TypeScript file, which is a superset of JavaScript. All TypeScript is JavaScript. JavaScript is not TypeScript. And it will, sorry, I should correct that. TypeScript is transpiled into JavaScript. It isn't pure JavaScript at the beginning. It gets changed when we build it and becomes JavaScript. Okay, but you can write pure JavaScript inside of TypeScript. That is possible. So we're going to import component from Angular core. Okay, component is what gives us this attribute up here, right? This is an attribute in Angular. This is decorative information that helps the tooling understand how to get more information about this class. And what this is going to tell us is my selector is going to be called app home. Normally, the naming convention for this is the name of the module you're in with the name of the component you're in, right? And the way this works is you'll see in here, bad example. I'll come back to that in a second. In here, we have app home as the selector, and we have a template URL. The template URL is what says, hey, go bind this information, go bind this view of the data, right? So we can control access to the data in our component background, our code behind file, essentially. And in the view file, the HTML component is the actual markup that would get rendered into the page when we call it. So if I change this to Angular signal demo. Now when you go here, you can see the loading happened. Once Once IIS Express is open and running with this, I don't need to be running the application for that to be hooked up. If I kill this, the site will die. But it will automatically rebuild while it's hooked up. If that goes awry, which it can do, you build your application, you run your application again. That's not a problem. Okay? One downside you do get is you don't, once you disconnect, you don't get, maybe you do. This could be recent, this could be old. It would depend, right? The way we can test that is with that window open. We can change this once more and say, welcome to my Signal. I've got to keep remembering to use the actual name, Signal R application. Now when I save this, yeah, you see nothing's happening here, right? But the site does update, which is fine. If I was running, this would have changed as well, because it would have shown me rebuilding. When I say rebuilding, the site has to build the JavaScript files, because like I said, TypeScript gets transpiled to JavaScript. Transpiled meaning that it isn't quite like a program where it becomes something very different when it's built. It just kind of moves it all around and makes it actual valid JavaScript to be sent to the actual browser. And you can see it's preparing everything, tightening everything up, making sure it's ready to deliver to the browser so it's nice and fast. And we can update. So that's our home component. Our next piece is our counter. Okay, so our counter is here. We have counter.component.ts, counter.component.html. So if I open a TS file, I can see my selector is app counter component. Slightly breaking their own naming, but yeah. And template for this file is counter.component.html. Here we have a bit more implementation. Okay, we have some actual code set up, and you can see that we have a public current count and a method public increment counter that says this.currentCount++. If we look at our page, we'll see that we've got a title, we have some descriptive text, and then we have some more text, but inside of there we have this thing. What this is a token as such to tell Angular, hey, break into your code and figure out if I've got current count, and if you have, let's display it, right? So it looks at the code behind it and says, do I have a variable called current count? Yes, I do. I can see it. It's available. Let's put its current value in here. Okay. Then we have a button, and on the button we have an action. So again, this is an Angular event. A normal HTML button looks like that. You can't do that with Angular. You have to use their events, their methods, because it's hooked into the Angular framework, and I'll explain that in a second. So this is saying on click, increment call, because this is a parentheses, call increment counter. An increment counter is implemented in the code behind, and it says this.currentCount++, which will increment the counter. Now, Angular does this magic through something called watches, right? It is constantly monitoring this, and if it sees a change happen to something it's monitoring, it updates that, right? And how they do that is some extremely talented people who understand browsers and that entire pipeline a lot more than I do. But basically, they're always watching values for changes. They're always watching things for things happening. And they're hooking into some of the underlying events of the browser and doing all sorts of stuff. But as far as you need to care for right this second, as you're learning about Angular, we have a code behind file. That code behind file can have behavior. It can, so it could have alert current count. Okay. Now if I go here, when I increment the number, it will alert what the count is. So that's behavior, right? So we have 1, 2, but you can still see it's updating the number there. So our class file, our file behind, sorry, I'm just trying to make sure that's not distracting. Our file behind can have some behavior, it can have interaction with other components, it can do all sorts of other things. And our view are the two major components of any Angular component. This spec file, Angular by default will create this. You do not need to care about this. What this is a way of setting up tests. So once you get to the point where you've got enough components, those components may get pretty complex on the client side. You don't want to be spending a lot of time verifying basic behavior when you just go in to change the query, or change a button text or something like that. You just want to make sure the app still works. And this is a way of doing it. I have tools installed that may or may not run this. You do not need to worry about this. Okay, so you can see that did not like that. That's pretty impressive that it even tried. But you can see every time it runs this Jasmine tool, and this Jasmine tool says, nah, I'm not going to try and fix that. That is beyond what I'm trying to show here. And these tools are not installed by standard in your Visual Studio. But anyway, this is a way of saying, hey, for the counter component, if I set up the component, before each test, make sure the component's working, it's built, then I'm going to create it, and I'm going to call some other stuff, and then it should display a title, right? So we're going to check to see if the actual page that we render, so what it's trying to do is render that counter component outside of everything else. It's going to say, does it have an H1? And that title should say the counter, and this is descriptive text. This is called BDD, Behavior Driven Design, right? It should start with count 0, then increments by 1 when clicked. So we were saying we've got a strong element that should show 0 when I click the button, right? I'm going to get the button, then I'm going to click it. I'm going to make sure that all the changes have figured out. I expect the value of that now to be 1. It's pretty clever. You don't need to deal with that right now, but it's worth knowing they exist. And that's a whole discipline unto itself when you get in there. So that's the basic rundown of components. There's one other area that I wanted to cover back around on, was the selector, right? In our app component HTML, we have app nav menu, right? If we open the app, we've got a menu up there, but we don't see where that's magically rendered, right? We have our app module here, right? And it has nav menu component, home component, counter component, fetch data component. These components we know about, right? We've navigated through. We've seen our home. We've seen our counter. We've seen our fetch data. They're all being rendered fine. Nav menu is here. This has 3 components: CSS, HTML, and TS. So we know our code behind. And here we go. Our selector is app nav menu. Our selector is app nav menu. That is what pulls that component into the page. So that is what's saying, hey, Angular, here you go. build this component out and replace these tags with whatever's built out of that view. This also includes a CSS file of its own. That CSS file allows you to set up specific CSS for this component alone. So you can have localized changes to the CSS that ultimately get built out, but do allow you to be very specific about this control's CSS. There are some exceptions to that, but you don't need to worry about that right now. You'll discover them on your own if you got to the point where you're actually putting CSS in for these. It's to do with what styles what when. And this has some behavior, but yes. I believe that's pretty much that. Okay. So we've covered components, we've covered the basic run through of how the app starts up and what controls it has. And we are now going to add a component. Okay? So there's a few ways of doing this.